Let's talk about one of the most important components on your electric fencing system and the single most common cause of poorly functioning fences and other fence problems, and that's your grounding system, also called earthing system in some parts of the world. The hot wires on your fence are only half of the equation. When an animal touches a hot wire on the fence, the current has to complete the circuit and flow back to the energizer. And it does that through the ground circuit. And in most cases, you're going to have hot wires on your fence, and you're going to have ground rods driven into the earth, and those are going to be hooked up electrically back to the ground terminal on your energizer. So when the animal touches the hot wire, the current can flow through the animal, through the ground, back to the ground rod, complete the circuit, and that's when they get the shock. So if you have inadequate grounding, or there's problems with your grounding system, then your animal's not going to get the full shock that your energizer is capable of delivering. There's a few rules of thumb that I'd like to go over, and the first one is the types of materials to use in your grounding system. So this is a 6 foot by 1/2 inch galvanized steel ground rod, and this is the ideal. Galvanized steel is going to hold up to the potentially corrosive environment underground, and unlike rebar, which is a really common one that we see, rebar is free. A lot of people use it as their ground rod, but the corrosion, the oxidation that you get on the outside of regular mild steel is not very conductive. So if you're using rebar as a ground rod, the rod is not going to be able to receive electrons as easily as a galvanized and much more conductive ground rod would be. And then you should hook it up as well with an insulated hookup wire that should also be galvanized, 12.5 gauge galvanized steel. In this case, this is aluminum coated galvanized wire, so it's extra conductive, and these types of insulated electric fence wire are a great choice for hooking up your ground rods. As soon as you're using something like household electrical wire in an electric fencing system, a lot of people will be thinking about the size of the wire in terms of how much current it can carry. And a 12-2 household wire, that may be adequately sized to carry the current. However, the insulation rating on those wires, household wire is only rated for 600 volts. You can read it right on the jacket. And your electric fence, you're going to be putting out 7, 8, 9, or 10,000 volts on your fence. So that current over time, it might not happen immediately, but it'll leak right through the insulation jacket on that wire, and it'll end up creating a short. So stick with electric fencing specific materials like insulated hookup wire and galvanized ground rods. In terms of the size and amount of ground rods, for any permanent electric fencing installation, a minimum of 3 ground rods is a good idea, and 3 6-foot ground rods. But definitely if your energizer is 6 joules or more, then you absolutely need a minimum of 3 ground rods. And a rule of thumb for that is that you should have 3 feet of ground rod for every 1 joule of output that your energizer has. So you can do the math on that, but start off with 3 minimum, and then every joule above 6 joules that your energizer is, every 2 joules higher, add 1 more ground rod. And that may sound like a lot. If you have a really big energizer, you may need 10, 12, 15 ground rods, but that's the size of grounding field that you need to receive all of the electrons back in order to complete the shock. So you've got 3 feet of ground rod per joule. You're using galvanized steel and galvanized hookup wire, and your ground rods should be located in a location where they're not going to be easily damaged by machinery or traffic or cause a danger to animals. So I prefer to put mine directly in line with a fence and kind of put it right up against or almost underneath the fence. And you want your ground rods to be 3 meters or 10 feet apart between them. So that means that they'll function as an array, as individual ground rods. If you put them too close together, they lose efficacy, and each one kind of just functions as one ground rod. 10 feet apart and hooked up with 1 continuous wire all the way back to the fence wire or back to the energizer if that's appropriate. Think of your ground rods as an antenna in the ground, and they're sitting there gathering up any closing any potential between the electricity that's going out on the hot wires of the fence and collecting it back up. So if you have a bigger antenna, you're going to be able to more effectively close that circuit and create the shock that you want. So you're going to want your eye and ear protection for this part. And I like to start driving the ground rods with a post driver. This is a nice small diameter post driver for Gallagher line posts. So you can use that to get it started. That drives it down until until it hits the ground, and then you can start using your sledge. If all you've got is a sledgehammer, it's a little harder to start up high, but sometimes I'll stand up on the tailgate of a pickup truck or something like that. So yeah, don't be jealous if your ground isn't this easy. Most of ours isn't either. But we picked a lucky spot for filming. I like to drive the ground rods in and until they're just a little bit below the surface of the ground, and that way I can make my electrical connections, bury my wire a little bit so it doesn't get torn up, and then kind of put the soil back to the top of the ground rod so it's not going to trip up any animals. So now let's talk about how to wire it up. Okay. All right, so here I've got my high conductive lead out cable. As I mentioned, galvanized steel with an aluminum coating. And I like working with this one because it's a little more flexible than some of the other lead out cables that can be pretty stiff, but any of them will work. And there's no super easy way that I've found to strip this stuff. It's pretty tough, but it is about 12 gauge wire inside. So your regular household wire strippers with the 12 or 10 gauge space will do it. So I like to do it about 4 fingers back from the end. And so then I'll clip onto it with the 10 gauge hole, and I'll kind of clip around it a couple of times to get through that thick jacket, and then I'll rotate it just like stripping a normal wire. Then the tricky part is getting it off. So I like these electric fencing pliers because they have parallel jaws. So when you grab a hold of it, it'll kind of hold firmly onto the whole jacket. You can step on it and then start to twist and pull it. And once you've got it a little ways off, you can pinch right onto the end of the wire and start pulling it off, and then you're not putting any additional pressure on the wire. And it takes a little bit of force to do it. It's nice to grab the end because then you can pull it off with a twisting motion and get it right off of there. If you can't quite do this, you can strip it off with a knife, and I'll show you how to do that at the next ground rod. But we're going to use one continuous wire to hook all these up. So we'll start with this one right here on the last ground rod. For this final ground rod here, we're just going to strip the end of the wire like we demonstrated. And I like to put a bend in the end of the wire and basically double it over so I have a little bit more contact area with the wire. And I'll just put that bend in it, kind of squeeze it, and then I'll bend the actual insulated part of the wire as well so that my little loop is pretty much vertical. Like that. If you bend it just like this, then you have plenty of contact area on the ground rod, and then it turns to stay buried underground. And this is going to be even with the top of the ground rod. Okay, so we're going to use a purpose-built ground rod clamp for the size ground rod that we're using. I like these where it's a single piece with a bolt into it. So I'm going to have this come up the back of the ground rod, and I'm just going to slip this ground rod clamp over the wire and slide the insulated hookup wire up behind it on the opposite side from the bolt. Now I've got it finger tight, so it's holding there. You can use an open end or a crescent wrench or socket to get onto that bolt with this style of ground rod clamp, and just tighten it down nice and snug. I've cut in a small trench here just to keep the wire just below the surface. It doesn't need to be deep. I'm just trying to prevent there being mechanical damage, or just trying to prevent livestock from ripping it off any of the ground rods or it being subject to any mechanical damage. So As I go down toward the next ground rod, I'm just gonna flip the sod back over and just bury this down. So when we come to the next ground rod, we're gonna have to take off some insulation from the middle of this wire, which is a little more tricky. And I find it easiest to do it with a utility knife. It takes a little bit of practice. But what we're gonna wanna do is create kind of an upside down T with the stripped part of the wire. So I would start just before the wire comes to the ground rod, and again strip off maybe about 4 fingers worth of the wire, but you want to start just before it and go 3 more fingers past it. So I'm going to do that same thing we mentioned before with the wire strippers. Make my chew into the wire from a couple different angles, and then rotate around a couple of times to get it cleared off. I'm going to get my 4 fingers or so down, do that again, and you just have to bite it from a couple of angles because it's so thick. And the tricky part is getting just the right angle to strip this jacket off without damaging the wire too much. So you'll see if you look at how this stuff is made, typically there's this outer layer, which is a thick plastic, and then there's an inner layer, which is more like the typical wire insulation that you're used to from household wires and things like that. It's a little stiffer than that. And so if you can get through that outer layer, you can just pop that part off and peel that away. And then you can get to work on the inner layer. Sometimes it's easier to take them off separately. If you do a great job, you can just kind of follow the wire down and get it so that you can peel it off at one end or the other. And then you've got a nice stripped piece to maintain one continuous wire. Then we'll bend that right in the middle, create kind of a bend, and then flatten it out. So much like the first one, we've got some good surface area here. Sometimes it can help to pinch that bend closed a little bit so that it'll fit inside your ground rod clamp. And if we did a good job, it lines up right with our ground rod so they can be snug and close to each other. Slip that ground rod clamp, open up the bolt, and slip it right over top again, just like we did on the other one. Get it finger tight, and then just use your wrench again to tighten your bolt the rest of the way down. Nice and snug. If there is any sort of sticker for the barcode or anything like that where your ground rod clamp is going to sit, I like to remove it just to make sure I have full electrical conductivity in that area. So I'm going to just bury this under the sod as I go here again. All right. As many ground rods as you have installed, you're going to repeat that last step up till you come to the last one, which is going to be the same as the other ones in the middle, since you have to strip off some of the jacket from in line. So I'm going to start just before the wire reaches the ground rod and strip that off. Okay. And then I'm going to work on the inner jacket just gently. That came off just fine. So right in the middle, bend it up. Okay. Nice and snug, and all my ground rods are wired up. So I'm just going to make sure I've got plenty of wire to reach over up the post and out the wire. So I'm going to cut it off over here. And this wire is so big that a lot of cutters, you might need to squeeze it twice in order to get through. Once you've cut that hookup wire to length, you need to strip the end of it to connect it to your fence or your energizer. Again, 4 fingers usually works for me, but you might need a little bit less if you're hooking it to an energizer. It's nice to have a little bit longer section stripped to hook it to the fence so you can make a good electrical connection. So rotating that around, and then we're going to step on it and use our parallel axis pliers to start twisting it, make sure it's moving off, and start to pull it off without actually squeezing the wire. Just like that. Once you've got that stripped and prepped, I usually feed this wire up behind any other insulator wires or anything else on the fence just to keep it nice and tidy. And even though it's all behind there and tidy, I always throw one staple at least at the bottom, and use your judgment. You may need more staples, but I like to put a little bit of slack in the wire before the ground rod and then drive in a staple. And I like to drive that staple snug with slack between the post and the ground wire so that if anything does pull, it's not too tight. There's a little bit of slack, a little bit of give. So this is going to be our ground wire. So what we'll do, now we fed it up through here, we'll just put a bend in the wire right here, and we can loop it around a couple times, loop it around that fence wire a couple of times, and then we'll use a joint clamp. So remember, an electric fence, these are electrical connections, and all of your connections should have some sort of mechanical fastener holding them down. Otherwise, there's just too much resistance in the connection. It can corrode over time and reduce the efficacy of the connection. So it's a good idea to use a joint clamp on every single one of your electrical connections, on the ground and on the hot wires. So as we mentioned in another video, there's a long leg and a short leg on these joint clamps. If you bring the nut out to the end, then the L will rotate around the short side and hit the long side. So you can put it over the wire and rotate it into position without taking off your nut. And then I like to wrap the wire around once or twice and then just have a nice parallel section where the two wires are together straight, and that's where I'll make my clamp. So I'll slide those together, tighten down that nut, and then get it nice and snug with your wrench. And that's it. So this ground wire is attached to our 3 ground rods by 1 continuous insulated hookup wire. So now we've just added 18 feet of ground rods to our system in a new location that's a kilometer away from our main ground field. And when we get the other wires insulated and electrified on this fence, this is going to be the grounding array for this entire pasture over on this side of the farm.